Hi guys, we're going to look at question 1 of the 2017 exam paper 1 today. So when Connor rings Kira's house, the probability that Kira answers the phone is 1/5. Connor rings Kira's house once every day for 7 consecutive days. Find the probability that she will answer the phone on the 2nd, 4th and 6th days, but not on the other days. Okay, so let's just break this down. So the probability that Kira answers the phone is 1/5. So let's say probability of A, she answers, is 1/5. So then we can write the probability that she doesn't answer, not answer, equals 4/5. Because she either does answer or she doesn't. Okay, and now let's take a look at what needs to occur for what they're asking to happen. So we're looking at not answering, so she doesn't answer the first day. She answers the second day, doesn't answer the third, answers the fourth, doesn't answer the fifth, answers the sixth, and then doesn't answer on the last day. Okay, and so if we want to look at the probability of all of these things happening, of this whole thing happening, then we can break it up into its 7 pieces and look at the probability of each individual thing happening. So the probability that she doesn't answer, so this is 4/5, 1/5, 4/5, 1/5, 4/5, 1/5, and 4/5. And so the probability of all of these happening, well, that's just the product of them all, because these events are independent. So if she answers one day, that doesn't tell us anything about whether or not she's going to answer the next. We still just know that it's just 1/5 always. So these events are independent. So all of these happening, her answering the second, fourth, and sixth, but not the others, is just the product of these, which is 256 over 78,125. And now you can write this in decimal form if you want, but there's really no need. So that's it. Just break this event up into the events that need to happen, and then look at the probability of those individual events. Okay, now let's take a look at part B. So find the probability that she will answer the phone for the 4th time on the 7th day. Okay, so again we have the probability that she answers, that Kira answers, is 1/5. And the probability that Kira doesn't answer is 4/5. Okay, and so now what needs to happen for this to occur? Well, we want Kira to answer for the 4th time on the 7th day. So for this we need 2 things to happen. Kira to answer the phone 3 times in the first 6 days, and then we also need Kira to answer the phone on the 7th day. On the 7th day. Okay, so that's 2 events that we need to look at, and then the probability that both will occur will again be the product of those 2 probabilities. So let's call this B and this C, just these two events, probability B and probability C. So the probability of B, well, we need her to answer three times in the first 6 days. So how many ways are there that this can happen? Well, first we can count the number of ways this can happen. So there's 6 days and she answers on 3. So we pick 3 of those 6. So 6, choose 3. And then we'll look at the probability of each of those individual events. Well, she answers 3 times. So that's 1/5 cubed. And she doesn't answer 3 times, so that's 4/5 cubed. Okay, 4/5 cubed. And if we put this into our calculator, we get 256 over 3,125. Okay, and so in general, the probability of some event happening n times out of k, happening k times out of n. So in this case, Kira picking up the phone is the event, and k is 3 and n is 6, 3 times out of 6. So this probability, the formula is n choose k, the number of ways it can happen, and then the probability of the event happening to the power of k, the probability the event happens and then it happens k times, and the probability that the event doesn't happen, 1 minus the probability of the event happening to the power of n minus k, the amount of times it doesn't happen. So that's our general formula, and so then in this case it just looks like this. So that's the probability of B. And so now let's take a look at the probability of C. The probability that she answers the phone on the 7th day, well, that's just the probability of her answering the phone on any given day, which is just 1/5. So the probability of both happening, probability of B and C, well, that's just the product of the two, the probability of B times the probability of C, which is just 256 over 3,125 by 1/5, which is 256 over 15,625. Now on to part C. Let's move this up. The Connor rings her house once every day for n days. Okay, so write in terms of n the probability that Kira will answer the phone at least once. Okay, so we're looking for the probability that Kira answers at least once. Okay, and now there's sort of a trick whenever or often when you're asked the probability of something happening at least once. I mean, you could add up, so you could look at the probability that she answers once, the probability that she answers twice, the probability that she answers 3 times, so on and so forth, up to the probability that she answers n times. But that's a lot of work and it's not very efficient. But there is a better way of doing it, sort of a trick. So instead of looking, what's the opposite? What's the opposite of her answering at least once? Well, the opposite of her answering at least once is her not answering at all. So the converse of this is the probability that Kira doesn't answer. So either Kira doesn't answer at all, or she answers at least once. One of those two things have to happen. And they're opposites of each other. So that means that their sum, so let's call this PA, and let's call this PB, just for use. Then we know that the probability of A happening plus the probability of B happening is 1, because they can't both happen at the same time, and one of them has to happen. So it's like binary, either A happens or B happens. Okay, and so we're looking for the probability of A, and so instead of looking directly for it, we're going to use this formula. The probability of A equals 1 minus the probability of B. And we're going to look for the probability of B instead. And you'll see in a bit why this is a much easier way of going about it. So the probability that Kira doesn't answer for n days, well, she has to not answer the first day, not answer the second day, not answer the third day, all the way up to not answering the nth day. So we get 4 fifths to the power of n. She doesn't answer for n days in a row. So, and that's just it. The probability of B, of her not answering at all, is 4 fifths to the power of n. So then the probability of A is 1 minus 4 fifths to the power of n. And that's just it. Way easier, much easier way of going about it. And you'll typically want to do this when, so let's say they want to ask, what's the probability it happens at least once? Well, then you always want to do this. But it also might be useful. So let's say probability it happens, so some event happens at least 3 times out of 8, just for an example. Well, then we could look at the probability that it happens 3 times, or 4 times, or 5 times, or 6 times, or 7 times, or 8 times. Or we could just look at the probability that it happens at most twice. At most. And then there's less things to calculate. We only have to look at the probability that it doesn't happen, the probability it happens once, and the probability that it happens twice. So we only have to calculate 3 probabilities. So if this way makes you have to calculate less probabilities, then it's a good idea. And if we're talking about at least once, then it's always quicker to look at the probability that it doesn't happen at all, looking at the opposite. Okay, now on to part D. Find the minimum value for n for which the probability that Kira will answer the phone at least once is greater than 99%. So we know that in n times, the probability that Kira answers at least once is, well, we have a formula that we've just figured out. Kira answers at least once is 1 minus 4 over 5 to the power of n. Okay, and we want to find the minimum value of n such that this is less than 19 sorry, this is greater than 99%. So we're looking for the smallest value of n such that the probability that Kira doesn't answer at least once in n days is greater than 99%. Okay, well, what we typically try to do here is we let them equal. So we let these expressions be equal because it's hard to solve. It's harder to solve inequalities. So we let them be equal, and then we just go to the next n up. So if this is something like, let's say 17.354, then after 17.354 times calling, there's a 99% chance, but 17.354 times calling doesn't really make any sense. So the smallest n such that there's a greater than 99% chance will just be the next. So we'll just always round up from whatever we get here. So if we try and solve this, then we bring over this here and then bring this over here, and we get 0.01 equals 4/5 to the power of n. And now this equation is the question 4/5 to the power of what is equal to 0.01. And now we have a way of rephrasing this question in maths terms. So this equation is the same thing as this equation. The logarithm of 4/5, 0.01, equals n. Because that's all that the logarithm is. The logarithm is basically the question, the base to the power of what equals the thing in the brackets. That's just what the logarithm is. So, I mean, there's another way that you could do it, and I'm sure your teachers have probably talked about, take log of both sides, and then that brings down the n, and then you can work with that. But I think that understanding what logs are is more beneficial. And then you can just put this straight into the calculator, and you get 20.64. So, as we said, we need to round this up, so this becomes 21. So the smallest value of n such that the probability that Kira will answer the phone at least once is greater than 99% is 21. So if he calls 21 times in a row, there's a greater than 99% chance that she'll pick up at least once.